Bismillahirrahmanirrahim. Assalamualaikum and good day to everyone. So today I would like to continue our class with chapter 5, which is symmetrical components. So before we proceed to symmetrical components topic, so I would like to do some review on fault in power system. Normally, fault in power systems occurs due to many factors such as heavy rain or storm. It can be lightning strike, trees, animals, and others. Fault in power system, especially in transmission line, can be divided into two types. The first one we call as a symmetrical fault, and the second one we call as a unsymmetrical fault. Okay, for symmetrical fault, we already covered this topic in chapter 4, and meanwhile, unsymmetrical fault, we will discuss this topic in chapter 6. In chapter 4, we have discussed that a symmetrical fault consists of two different faults. We call as a first three-phase fault, and the second one is three-phase to ground fault. What is three-phase faults and three-phase to ground faults? How to draw the connection for both faults? So for three-phase faults, let's say we have three different lines named as a phase A, phase B, and phase C, and all these lines are connected together. So this is the three-phase faults. So meanwhile, three-phase to ground faults with the same lines A, B, and C, all lines are connected together, and these lines connected to the ground. So this is the three-phase to ground fault. Now we go to unsymmetrical fault. Unsymmetrical fault consists of three different types of faults. The first one we call as a SLG fault or LG. So SLG fault stands for single line to ground fault. So the connection of single line to ground fault is we have three different line A, B, and C. Only one line will be connected to the ground, or A, B, C, B, line B connected to ground, or A, B, C, A connected to the ground. This is for single line to ground fault. The second fault in unsymmetrical fault we call as a DLG fault, or we call LLG. So DLG fault, double line to ground fault, or sometimes we call as a line to ground fault. So how to draw the connection of DLG fault? We have A, B, C lines. So there are two lines will be connected together. BC connected together and connected to the ground. Or we have A, B, C, A and C connected together and connected to the ground. Or A, B, C lines, A and B are connected together and also connected to the ground. So these three types of connections we call as a double line to ground faults or line to line ground. Okay, the third fault in unsymmetrical fault we call as a DL fault or LL fault. So DL fault is double line fault or LL means line to line fault. So the connection for this fault we have A, B and C. So there are two lines will be connected together. Let's say B and C connected. This is for the L faults. So we have A, B and C, A and C connected together, and also A, B and C, A and B are connected together. So this is double line faults or line to line faults in unsymmetrical fault. So now we know what is the symmetrical fault connection and also unsymmetrical fault connection. Now we want to discuss what is the difference between the symmetrical faults and unsymmetrical faults. So from the fault connection, we can conclude that for symmetrical fault, we can conclude that all faces are shorted to each other or to ground. For symmetrical fault, the value of current and voltage are equal for each phase in terms of magnitude and equally displaced by angle 120 degrees. Meanwhile, in unsymmetrical fault involve only one or two phases. The value of voltage and current for each phase are unequal in terms of the magnitude and phase displacement. If any symmetrical fault or unsymmetrical fault occur in a power system, in transmission line for example, to solve or to analyze system for unsymmetrical fault is quite difficult compared to the symmetrical fault. Therefore, in order to solve or to analyze the system when unsymmetrical fault occur, we need to use a method that called as a symmetrical component method. To solve or to analyze the system that related to the unsymmetrical fault problems, we can use symmetrical component methods. We will discuss this topic in chapter 5. Okay, that's all for our review for today. Fault in power system. So I hope all of you can understand and can compare what is the symmetrical fault, what is the unsymmetrical fault, and why we need to use the symmetrical component method to solve the unsymmetrical fault problems. That's all. Thank you. Assalamualaikum.